Hi, I'm Dave Robinson, Chief Data Scientist at DataCamp, and welcome to another one of my screencasts where I'm going to analyze some data without ever having seen it before. This is the sixth screencast. I've had a lot of fun in all of these, and I'm going to be taking a look at, looks like Baltimore bridges this week. All right, so every week we analyze some data from Tidy Tuesday. That's a project done by our studio and the R for Data Science online learning community. And in this case, we're going to be looking at Maryland bridges. All right. So Baltimore is an American city in the state of Maryland, and it's looking at which bridges in the region are listed in poor conditions by the Federal Highway Administration and which have been poor for several years. Doesn't mean it's unsafe. It means that if it were structurally unsound, it would be closed. It could be a nuisance, damaging to cars, particularly tires. All right. And the data comes from the Baltimore Sun data desk. Looks like they have a whole GitHub for themselves. That's cool. That's really cool. All right, I think this is going to be a great analysis. So we have our data dictionary. It looks like, what are we looking at, 4, 12, that's like 13 columns. And here's the CSV. Every week we do the same thing to analyze the CSV. I go to the raw link, I copy it, I go into our studio, create a markdown file, and in this new chunk, I say Maryland bridges. And I'm going to quickly load up library tidyverse. Right, and read underscore CSV with a link to that file. I should probably call it Baltimore bridges, match the description used here. And here's the data set. Almost always my first step, well, I'm going to save this file first. Almost always the first step is to view it. All right, we have 2,079 rows and how many? 13 columns. Okay, it's not the biggest data set we've worked with. And, oh, that's cool. There's going to be some cleaning involved because we have vehicles here is going to be, we need to tell that it's going to be a numeric column. We have inspection month and year. It looks like it's often going to be, am I right here that it's often going to be the same bridge over time? I might not be. I'm trying to see, is there a bridge, is there like a column called bridge? No, but there's a location. For example, I wonder, are these two the same bridge? They have they have the same longitude and latitude. Like, could it be the same bridge of 2 months? No, I don't think it is. Though it does have the same values here, number of vehicles. So maybe it is the same bridge. Same month, same year. Okay. What I'm discovering is we have this carries column. And look at this. This is already one thing to know what the data is. This data is duplicated. We have 2 rows here. Exactly the same. As far as I can tell, the same everything. Maybe I'm missing something. All right, do I see anything about that in the data dictionary? We saw some duplicated data in one previous screencast about horror movies. This case, it seems pretty straightforward in terms of it's always... Now, it's not exactly the same. These 2 rows, this IL and this OL, I'm going to go back into this link a second. What street is carried by the bridge? Okay. Average daily traffic. Yeah, they're really pretty often they're duplicated. Here it's duplicated as well. Okay. But year built is different between these two. It's different between these two. That's a little bit frustrating. I'm really nervous about duplicated data for sure. I do notice, though, it could be that these are 2 consecutive bridges, for example. These two carry the same street were built in different years, but that could explain why they have the different average daily traffic. Okay, so maybe they're two different bridges that are adjacent to each other. Still, I'm pretty nervous about that. Here's two Jumpers Hill roads, slightly different average daily traffic, inspected at different points in time. It looks to me like vehicles was already cleaned to create this column. Okay, all right. Vehicle traffic, and then I'm going to quickly check that. We're still in the data cleaning step. I'm still just taking a look at all the columns, seeing what I can learn from them. Average daily traffic and vehicles. Yeah, we can drop the vehicles column. In fact, let's go ahead and do that. All right, and I'm going to find out if I count the lat and long sort equals true. We have lots of things that have the same location. Now, what if I count lat, long, and average daily traffic, which we saw was duplicated? And what if I threw in carries? Let's start with that. Carries being, again, the street that it's carrying. Okay, we have... Okay, here are only a handful of ones that are exactly the same. I'm going to remove the carries and say what pairs of streets in the same, pairs of bridges in the same location. Okay, it could just be that these are some of these just adjacent bridges. All right. The bridges that are right next to each other. Okay, so for now I'm going to leave in the duplication. Maybe we'll take a closer look into it later. All right. When it says poor for several years, something I wonder about poor, does that, and I did wonder that already, do we have, so I already counted lat, long, carries. I don't feel like we have data over time here, because if I look at lat and long and carries, we have only we have a good number of rows. Oh no, I was looking at long average daily traffic. That actually would not be appropriate if I were looking at do we have data over time. Yeah, it'd be lat, long, and carries. The same bridge would presumably have the same road. And I only have 13 data points, unless bridges are changing location, where they're changing over time. This is a case I'm actually going to glance at the article. Oh, I know this author from Twitter, Christine Zhang. Great. All right. What did it say about time? Yeah, so I don't know from this data if we can figure out changes over in bridge status over time. Okay, I'm not going to take a look at that yet. I'm just going to move this select minus vehicles up to the cleaning step. All right. I'm going to pretend they're all individual bridges. Looks pretty close to true. And start going from there. All right. My first question, bridge condition. I'm really interested in that. I'm going to start with counting it to sort true. Most bridges are in fair condition. Some are in good. Not as many are in poor. All right? Good to know. I wonder how it's been changing based on what year the bridge was built. It certainly would make sense if the bridges that were built a long time ago might be in poor condition. They've had more time. So to find that out, first I'm going to need to count them. Say count year built. When were the most bridges built? And I might want to graph that. Year built. And line graphs are almost always a way to do a visualization over time. Okay, so we have bridges going back to 1900 as the earliest year we have on record for bridge being built. Peaking in the 70s, my understanding, a lot of infrastructure projects, and then been declining since. Maybe decreased spending in infrastructure, maybe just as many bridges as they need were already built. Okay, and so I can tell that I don't quite have enough data. I don't have enough data to look before 1900 for sure. I might even want to say, before I look over time, I think I have one from mid-1800s. That's kind of cool. And say, since 1900. And I might want to, instead of looking at years, look at decade. Say, I'm going to... We've used this trick before. This is divided by 10, but a truncating division. And it's a truncating division where I actually say divided by 10, then round it down, and then multiply it by 10. That rounds each to the decade that it's in. And usually if I make a graph out of this, and it's already, I actually think, a better graph, I'm going to need to say expand limits y equals 0. Number of bridges built this decade. I'm saying in Baltimore. I don't know whether it's just Baltimore, if it's in all of Maryland, but yeah. So here's data. It looks like they peaked. It's a slightly better graph than the line graph per year, less noisy. Okay, I'm gonna quickly set up my theme. Say theme set theme light. It's my favorite built-in theme. Okay. That's the start of a graph. Now that I have some data over time, I can ask, how has the condition changed? Now, how does the condition of bridges depend on the year, on when it was built, on how old it is? When I do that, I'm going to have to quickly check something. Notice that the inspection year, if some of these bridges were inspected in the 80s, it wouldn't be fair to compare them to a modern inspection year. So they're all 9, 13, 14, 15, 16, 17. Oh, this must be after 2000. We're going to check this in the data dictionary, but this must be after the year 2000. Year of inspection. It doesn't tell me that. That's a bit odd. I'm just going to quickly confirm that I'm looking at the right column and everything here. The inspection year. Oh, I guess, that makes some sense if people were just writing it down on like piece of paper. That they would say 0716, and then when it was parsed, it would look like inspection year. I'm actually going to put that in the cleaning step to say inspection year. Year equals this plus 2000. It's going to be it's going to be a bit better. It's going to be a bit better data, because then I can say count the inspection year, and it'll actually be meaningful. 2015 through so almost all bridges were inspected in 2015, 16, 17. I don't need to worry so much then about like how many years old is it. Almost all of them were measured in the same 2 years. So good. I'm not going to need to include that in this data. If some of them were inspected in the 90s or 80s, I would definitely need to worry about that. Okay, so now I'm going to ask a question about the good, fair, poor. I have a few ways that I can ask that. I could say, what percentage of them are good? I'm probably going to ask it that way because I noticed it wouldn't make sense to say what percentage are poor, because it's going to be a very small... I could take a look at that, but it's going to be a very small fraction. I could look at what percentage are fair, but that doesn't make sense to say what's in the middle. You want to say what's on one side. So I'm going to say what percentage are good of bridges within each decade are good. I'm going to add this decade. I love having decade as a column. So I'm going to add it in my cleaning step up here, right when I read the data. I'm going to go, after I read the data, I'm going to remove the vehicles. I'm going to add this decade column. And then I'm going to group by decade down here. And I'm going to summarize for what fraction are good. So the percentage that are good are going to be, it's mean. This is a really great trick for getting a percentage out of a column. Say mean bridge condition equals good. All right. So no bridges, but these are, whenever you have a decade, you always want, whenever you have a group by and summarize, you almost always want a total column. Yes, we can tell we really want we're not going to have a good time unless we look only since year is at least 1900. We're going to have a good time in this aggregation. That's right. I think they wrote year built or year built. Yep. Okay. All right. So we see a really big thing here is the newer bridges tend to be much more likely to be good. That makes loads of sense, of course. Both older bridges might have been built with older technologies, and they have had a lot longer since to maintain and had more time to decrease in their and in their upkeep. So here's where we can make a graph where we say decade percent good geom line. Anytime we make a line with a line plot with with scales on one axis, I want to say labs equals percent format. I'm going to quickly load up the scales package up at the top. Labels equals percent format. That's good. Okay, so we actually see this is an interesting graph. I think there's a change here where most bridges built before 1970 we would not consider in good condition, while a majority of bridges built, I can actually say, though it doesn't matter how long before 1970 were built, while majority bridges built since 2000, 1980, really majority since 1990, but the vast majority of bridges in 2000 are in good condition. Okay, so that's a top-line conclusion. That's why I actually wrote a sentence even in the middle of this analysis. I said, let's write a sentence where we actually explain what we would get out of this graph. It's a top-line conclusion. Okay, that's interesting. What else affects it besides the year that it was built? I'm certainly going to be interested in average daily traffic. Improve cost thousands. I wonder how much non-missing data we have in there. Okay. I actually also wonder, I'm gonna stick with this first. Owner and responsibility. I wonder how often they're different. Are they different? Also, is it Baltimore or is it just Maryland? Oh, sorry, pardon me. Is it all of Maryland or is it just Baltimore? Probably the Baltimore area. No, maybe it's the whole... I'm going to change the name to Maryland. I think that they call it Baltimore Bridges because this was the Baltimore Sun that published it. But I'm going to quickly change the name. This is a little pet peeve. You'll thank me later. Okay. Maryland Bridges. What I'm interested in is count the owner and the responsibility. How common are particular pairs of them? All right, vast majority, state or county highway agencies, or the state toll authority, okay? It looks like in the vast majority of cases, the owner and the responsibility are the same. The big exceptions, let's look at, would include some have an owner of private, other than railroad, state highway agency, and one, by some I mean 3, and in one case, 2 cases, the cases they're a little bit different. This tells me in other words, I could say owner is not how often is owner not equal to responsibility, and in 5 cases. This is important because when we're analyzing, we want to know: do I want to analyze both of them? Like, how often is the owner not responsible, and does that mean something? I couldn't do that. The data is telling me I want to just look at one of these columns. I'm going to take a look at... I'm going to just stick to responsibility. I'll tell you why is that in these 3 cases, I think that lets us lump them in with these ones that are in the state highway agency. So I'm going to stick with responsibility in this analysis. I don't know what the difference is. It's not going to make a big difference in any of our analyses. Group by responsibility. if I just counted, this is a not a bad graph to make. If we're starting to look by responsibility, is to make a geom call. I make this kind of plot so often. What I'd say is reorder responsibility based on n. And I almost forgot to coord flip. Now I can, I probably want to make a couple other changes. I want to say, now remember I've got the forecats package. We've seen me do this before. I'm going to say fct lump responsibility. I want only the top 6. That didn't work. fct lump responsibility is lump this. Oh, right. I need to do it before I do a count. So I actually have 3 steps here. I actually don't need to mutate to lump them. I'm like, oh, I do this all the time, and yet I can still get it wrong. What I do is equals reorder of responsibility. I'm going to use fct reorder. It works the same as the built-in reorder. But it's in forecats. I'm already using other forecats packages. It's nice to keep it consistent. What I'm doing is I'm counting the lumped version. And I actually now know that the right amount of lumping to do is 4 levels. And I probably also want to say, I probably want to replace NAs with other, because an NA is basically an other. I want to say responsibility equals other. So this would give us an understanding if we wanted to say who's responsible for the bridges in this state. There's a handful from areas like the Army or the Navy, but really we're looking at state or county highway agency, the toll authority, or a city and municipal highway agency. Okay, I start with that graph, and then I can start asking questions around how, for example, they were built. So if I say, let's see, I want to make this graph, but I want to make it differently for each of the owners. What I would do is say, let's change the responsibility to other. Let's mutate to add this. Oh no, let's count this, but also count the decade. Also, I do want to filter by year built is greater than 1900. Count that in the decade. I'm going to start just with this counting. Oops. Oh, right. Instead of counting, I want to group by decade and then summarize. Okay, so this gives me a graph where I can say that in 1900, there are 9 bridges built by the City or Municipal Highway Agency in the year 1900, and and none of them could be rated as good. That did change over time, and by 1990, most of them were rated as good. Okay. Notice that once I have this graph, I can actually once I have this data, I can actually pipe it forward in the same kind of graph we made before, and say color is responsibility. Is that going to work? It's about right. Cool. And we actually see there's not a huge difference. I'm not seeing like the ones that one agency is responsible for are way better than the others, except, take it back, the county highway agency does have some bridges, not a ton, from before 1950 that were higher, that were still rated good, whereas the other agencies have basically none. That's somewhat interesting. I'm going to change this a bit. When I look per decade, I get myself in trouble because we see this sawtooth pattern. I think that's a lot of noise. I could create confidence intervals for each. I'm not going to do that this time. I'm going to just explore the data, get a little bit more of a feel for it, and get the sense that, am I right that some of these numbers are really low? Well, other is really low. That makes sense. I should probably filter out the other. Okay, I also might... Now, all these numbers, they could be worse. Some things, like City Municipal Highway Agency having only one bridge in the last 10 years, that we can't do much with. But maybe what I want to say here is I'm going to filter for not is an A responsibility. Actually, I don't even need that. All I need to do is say filter responsibility is not equal to other. That'll drop the NA as well. It's at it. So now I'm lumping these 4 responsibilities together. I like that graph a lot more. Just getting rid of that other category. All right, so what we're showing is this pattern holds for all agencies. It looks like the state toll authority does have, for example, a bunch of bridges built in. This will be built in the 90s that are not well rated. One of the reasons I'm showing this graph is I didn't immediately say by each responsibility who has the best bridges, because some of them are it's probably going to be confounded over time. This pulls out that confounding factor. We could have looked at it originally, but I kind of like looking at it this way, and we can say which curve is on the bottom. All right, so I'm going to add a little bit of information to this. We say percentage of bridges rated good. All right, decade and responsibility. All right, so then we can say the county highway agency has the most bridges rated as good from before 1970? Consistently has the most bridges. 1970. State toll, is that which was the one that dropped? Yes, the state toll authority is underperforming in bridges built in the 1990s. We're just noticing that because everyone else is catching up to the majority of bridges being good, but not the state toll authority. Okay. All right. That was kind of interesting. I think we probably want to look by traffic too. I think, yeah, I don't know about you. I'm really interested in in that column about. Let me view the data one more time. Average daily traffic. Yeah. The cost, I'm interested in the cost, but it's just so often missing. I think it's going to be a little confusing. We might take a look. We might that later. We might not. Okay. So I'm going to say Maryland bridges. Whenever I have a column like average daily traffic, the first thing I do is almost always make a histogram. And I can tell you this histogram is going to have to be on a log scale. I'm not going to make it on a log scale yet, but we're going to want it to be on a log scale. The reason we want it to be on a log scale, his histogram of average daily traffic, is a lot of bridges are squeezed down here. So we're stuck out here, zoomed out, able to say, oh, most bridges don't have much traffic. Well, that's true of just a lot of data. We can say there's a peak up here. Actually, that's a little interesting. There's a peak up here of bridges with a large amount of traffic. I bet these are ones in Baltimore. We're gonna find out soon when we make a map. But yeah, But we also have lots of bridges down here. But as I was saying, almost any time we make a graph like this, we want it on a log scale. I don't know that this is so much more helpful. We see a peak up here. What is that? 100,000. Whenever I have a graph on a log scale, I usually not whenever, but in this case, I usually want a comma format on that x-axis. Doesn't that look nice? That looks number of cars that cross it every day. Okay. One thing this is telling me, so this looks like it's a roughly log normal scale. So what I mean by log normal, I mean that the log is very roughly, we have this kind of bell curve shape. So we have no bridges under 100. That might be a feature of the data. Not surprising, 100 is not a lot of cars cross a bridge in one day. But the median bridge, about 10,000 cars. We have this kind of skew left here that's not too helpful. But it's telling me that the categories of 100 to 1,000, 1,000 to 10,000, and either 10,000 plus or 10,000 to 100,000 and then 100,000 plus. It's telling me those will be somewhat solid categories. Those will be categories we can kind of work with if we want to analyze this data. So why am I looking for categories? Because I want to look at the relationship whether average daily traffic affects the condition of a bridge. I am going to do this only for recent bridges. It's hitting me that when we want to look at both these this data, we want to look at like bridges that were built. We saw there's an effect over time and there's an effect of average daily. I'm gonna just look at recently built bridges. By recent I mean 1990 onward. Let's do is say, let me see, where am I? Bridges 1990. Was it year built is greater than or equal to 1990. I'm going to take these 500 rows and say within these, let's group by traffic category. And I can say use the cut function. Cut's kind of nice, where I say, I think there's actually a built-in version of dplyr, a new version of dplyr, but I actually don't remember what it is. I would use average daily traffic, and I would say 0 to 1,000, 1,000 to 10,000, and then infinity. I could have added a few more breaks, but this is just 3 categories. And I can say within those categories, apply the same summary. I want to say what percentage of bridges are good. Again, so far I've been ignoring the difference between fair and poor, mostly because we saw most bridges aren't in poor condition. So now we can say, man, I don't like how cut formats things. Is there, oh good, I can say, can I give it a function? Wouldn't that be nice? No? Okay, I'm going to say labels. Let's find out if I can. Can I give it comma format? It hates that. All right, I can say less than 1,000, 1,000 to 10,000, or 10,000 plus. Oops. I'm mixing up. Oh, I wasn't giving it as an argument to cut. Doesn't matter. This is a fix. Oops. Okay, so this is saying there are 3 categories of traffic. So this is a somewhat common way to say is the relationship between these two. It looks like the ones that are less trafficked, little less likely to be considered good, but not much, and there isn't really a difference between these two categories of traffic. Okay, that's really interesting to know. This is hacking my data a little bit, but if I looked at the ones before 1990, that's pretty interesting. Now I'm really slicing it a lot of ways, but it does look like the not traveled ones before 1990, they are more likely to be the not traveled ones are more likely to be good, maybe because they're under more wear and tear. Okay, that a little bit interesting, but it's saying it doesn't have the same relationship we might have expected. Okay. Though I haven't said that there's reasons to believe that more traffic bridges get more maintenance, so maybe maybe the relationship goes both ways and it kind of evens out. All right. Let's look at the next step. I really want to start. Let me see. There's a few approaches we can take. I can make a map. I'm pretty interested in making a map. In fact, I'd really like to make a map. We could also try fitting a predictive model based on time and owner and the amount of traffic. Let's make a map. Maybe later we'll try a predictive model. I think there's things I'm more interested in predicting in other data sets. So let's try making a map. Okay. We've made a couple maps in these. We've had a lot of data sets that have latitudes and longitudes, so we've been making a couple of maps. I can say, what would I say? It's longitude is on the x-axis, latitude on the y, and say geome point. Immediately I get a graph. Charming. So I think it's roughly the shape of Maryland. And what I can do is add a borders to this. Usually I put it under the point. I can add borders, and I believe what I do is I say state regions equals, I'm going to find out if I spell it out, Maryland. Good. It is the shape of part of Maryland. I actually thought it was the shape of this whole thing. I'm not looking, I was looking at this. Sounds like it's the Baltimore region. Okay, so this is a map of a part of Maryland and a dot for every one of these bridges. We have I'm usually when I make a graph, I add in a theme void and a coord map. Coord map. There it is. Which gets the dimensions correct. Okay. Every one of these points is a bridge. What can I find out about these bridges? I'll tell you something I've been wondering ever since I saw this, which is what affects responsibility. If I say color equals responsibility, in terms of what is owned by the what is owned by state, what is owned by private, what is owned by whatever. This tells me I'm going to want to lump responsibility a lot earlier. In fact, I'm going to do it in my data cleaning. The truth is, it's really not worth keeping all the obscure versions of responsibility. Responsibility equals this. And I'm going to try graphing this again. All right, so we see some things. For example, it looks like, yeah, the main thing we notice are city and municipal. That's clustered around. I don't know Maryland geography at all. I'm going to guess that's Baltimore. It's at the center of this region that they're showing, and cluster of city makes a lot of sense that it would be Baltimore. We notice that county controls most of the bridges, interspersed with state. There's no one pattern. And then we have, I think this is a toll road that's controlled by the state toll authority, mostly all in a row. Okay, so that's something we learned from from what we have in this data. We can also use color to represent a continuous variable, which is the average daily traffic. I'm not too crazy about the color scheme, but I'm going to actually switch to a geome color gradient. It's scale color gradient 2. That's my favorite color scheme. I say low is blue, high is red. I think I always need to set the midpoint being I like to set the median of the data in question, which is average daily traffic. I'm saying median of average daily traffic. Why is everything... because the data is skewed, I believe. Okay, so this is where we probably want to add, I'm going to give one row for each. We probably want to say, all right, so the reason is because that almost everything here, actually that doesn't make it, oh yes, you can only go a little bit below the median, but you can go way above. That's because the data is log normal, as we saw earlier. Not quite log normal, but close enough. So you can't get very blue, but you can get very red. When we see that pattern of data, as we saw before, we usually want a transformation. I need to remind myself, is it trans is log 10? Is this the approach? Yes, but then I need to do the midpoint as the log of the median. Log 10 of the median. Look at that. Much better. Okay, that was few steps I had to do, but I need to say that the midpoint is right here. While I'm customizing this, I can say labels equals comma format and make it look even better. All right, this is my graph of the total traffic going on within each part of Maryland. So within each part of at least the cities that we're tracking. So there's your toll road there with high traffic. There's your Baltimore area, and the further you get from Baltimore, the lower the average daily traffic. I think it's what I would have predicted going in. I didn't know about the toll road. I don't have a driver's license, so This is a lot I'm learning here about roads. But yeah, all right. So that's some things that we learned. Now, yeah, what does the traffic look like geographically? That's a somewhat interesting question, but really we're probably mostly interested in the bridge quality. So I'm going to switch for a moment back to the bridge condition. We're going to see 3 colors, fair, good, poor. Do we see clustering? To me, at a glance, I feel like what I'm seeing is the Baltimore area has the most, has a lot of fair. Having said that, we could be being confused here by the size of the points. That is in points overlapping others. I'm going to shrink the points. I'm going to say size. I'm going to start with size equals 1. Yeah, that's a smaller size. Okay. Yeah, to me it really does look like we have a cluster around the Baltimore area with fair bridges. Most ones along the toll road, good. Hard to say. We looked earlier at this graph. That could be because these are a lot of older bridges. So I'm going to quickly glance at that confounding factor and say, let's look at one other thing. Again, whenever you want to make a visualization like this, we need to remember that the confounding factors don't go away. The age of the bridge doesn't stop mattering. It is having an effect on this this space. So if I were assigned to study this kind of thing, I'd use advanced methods for understanding spatial effects and correcting for confounding factors. I'm not really that well informed about it, so I'm going to. But at least we can keep taking a look at some of the confounding factors. So I can look at year built. Yeah, and just at a glance, we notice that a lot of the older bridges are in this Baltimore area. Okay, and the state toll road is, I think, fairly new. Very hard to tell from here. Okay, still not. Oh, I usually want to filter for 1900. Year built. So Baltimore's a very old city. If lots of bridges from back then, from a long time ago, and then it started expanding outward, entirely plausible. Okay, so let's just thinking about what to look at next. Yeah, what I'm thinking about now is counties. How many counties did we have? Because I'm looking at spatial, but I'm like glancing around. I'm trying to say this area. What if I really want to look at counties? How many counties do we have? Baltimore, we have city and county, and then we have our other areas. Let's color by county for a moment. Get a feel for... Yeah, so counties represent particular areas of geography. There's a point or two here that look a little bit odd, but mostly it's like if you're here, you're in Baltimore City, Baltimore County, Carroll, this looks Hartford, Howard, and Arundel County. Okay, so this lets us separate a little bit more. And one thing we could do there is we could actually say within those counties, what is the effect of change over time? Notice I keep copying and pasting graphs that I've made before. I'm going to do that one more time here. I don't need this graph. I won't delete it, but I don't really need this. I'm looking at this one where I looked at both responsibility and decade, and now I'm going to look at both county and decade. This is my attempt to explore the relationship between county and decade while controlling for color equals county while controlling for the effect of time. I don't want responsibility here. I don't want responsibility anywhere. I just want just county. And I don't need that. Okay. So if you control for time, it actually doesn't. Now, there's a lot of noise back here. How am I going to control for that? I could add confidence interval. I don't feel great about it. There's going to be some really wide confidence intervals there. I'm going to start just by looking at the data. Arranged by decade. And I found, okay, yeah, a lot of early years. We can say, for example, in Baltimore, only one bridge was built in the year 1910 in Baltimore City. Okay, and having said that, 10 were... Oh, look at that. We have a bit of data cleaning we need to fix here. We have Baltimore lowercase city and Baltimore uppercase city. Let's look at... I didn't notice that on the map earlier, did you? There it is. We have a few points, lowercase Baltimore City. Okay, what we do for that is there's a great function in string_r, which comes with tidyverse, where we say county equals string to title of county. That turns these to title case. So if I now say count county, did you spot it? I didn't spot it. Now we just have Baltimore City. All right. So now I can say, now I can try that one more time. I'm going to arrange by decade. Oops. Pipe to view. There we go. All right. A little bit better. Yes, there were 10 bridges built in Baltimore City in 1900, 10 in Baltimore City in 9 in 1900, 11 in 1910, and so on. I'm actually going to arrange by county and then decade. It's so hard to read this way. I'm going to start with the Baltimore City, and we see that, yeah, we have plenty of observations here, but we only have one built in the 1940s. And back in Anne Arundel County, we don't have any. And then we have one in the 1920, so it's really hard to make any conclusions in this area. Okay, so how are we going to draw a conclusion and say, I'm going to ask a question. I'm going to say, do some counties have worse bridges than others, and do some responsibilities have worse bridges than others? So here I'm going to fit a model. I'm going to use inference. Okay. So, and the question we're going to ask is, effect. I wouldn't quite call machine learning. We're not going to do a very fancy model, but I'm going to say effect of county responsibility and time on bridge condition. Do a really we're going to do a really elementary. We're going to be oversimplifying a little bit in this analysis, but we're going to take a look at the relationship between the number of bridges that are good and the and other variables. We can also look at traffic while we're at it. Okay, all right. So what we do is we want to fit a GLM here, a generalized linear model. I, in fact, am going to want to do a logistic regression on is the bridge rated good. I could have done other approaches. I could have said we could have put the bridges on a -1 to 0 to 1 scale. We could have had ordinal regression where we knew that it went poor, fair, good, and use, for example, a generalized additive model to understand that I'm not going to do these. I'm not going to include the difference between poor and fair. I'm going to keep saying percentage is good. It just happens to be a little bit easier to interpret. Little bit. So I'm going to say, add a column called good. Is the bridge good? And it's going to be bridge condition equals good. Again, other ways we could have coded this. That column is going to be true or false. Why is that important? Because it lets us do a generalized linear model. I can say, I want to predict, is a bridge good as a I would say data equals dot. I'm taking this data. This lets me do other processing if I want. I'm going to say, is the bridge good as a function of, let's start with the year it was built. I'm going to pass that to summary. Later I might use tidy for my broom package, but I'm going to start with summarizing this graph. Okay. This is fitting a linear model where I'm saying year it's built versus was it a good bridge. Okay. What we see is a strong positive effect. Bridges that are built later are better. That's good to know. Should we be fitting a linear model? No. Just a simple, an ordinary least squares simple linear model? No. And the reason is we see this nonlinear trend. It's straight and then it goes straight up. So if I took this data, even leaving aside that we have points before in 1900, and if I added, there's a quick trick for adding a best fit line. It's a terrible line. It thinks that it goes down below 0. It thinks it goes up. Now it would actually use logistic regression, which at least wouldn't go below 0, but it doesn't fit this data. Actually, the way that I'd want to graph this is I would say model, and then I'd say I would use the augment function from Broom. Broom, and I'd say augment. Broom is my package for tidying model objects into data frames. And here I take my model, and I take my original data, and I say, let's get the data, but add on my predictions in the form of a column called fitted. So then I'd end up saying, if I could say, take my my bridge year built. There it is. Oh, right. Yeah. Take bridge year built dot fitted and make a graph of it. I actually need to add one extra argument. This is the hardest thing I'm going to do today, the weirdest. You just need to know this from using augment, which is that in logistic augment dot lm. In logistic regression, you need to tell it the type of prediction to make. Type predict, not prediction type. My bad. You need to tell it its response. Otherwise, it's going to be, it's not going to give you the data on the, it's still not right. It's type predict. All right. I had an excuse for not figuring out how to use ggAnimate, but not... oops. Okay, did anyone see my mistake? Back when I called GLM, I was fitting a linear model. I did not tell it the type. I did not tell it family equals binomial to fit a logistic model of trues and falses. So I was using what they call the linear... I was treating falses as zeros, trues as 1. Big time mistake. Oops. Okay. Here was the graph that it made. Actually, I'm not gonna lie, that's pretty good. It fit a it took my lines and it said here's the shape of year built, where it says it has to fit a sigmoidal curve. Logistic regression doesn't have another choice, and this is the curve that it ends up fitting. Is that the best fit? I would have actually used a somewhat different approach. So we could compare that to the earlier graph. If I had more time, I'd compare it right here. I would use a spline fit. So the problem with this is it's always going to be shaped like this. It doesn't matter what the shape is, if it flattens out, if it peaks, if it drops, if it anything. It always has to fit this shape. I'm going to do two things. One is I'm going to filter out the data. I'm going to filter the data to be only since 1900. I really don't like having a handful of points before that. If nothing else, it's kind of messing with my pedagogical point when I'm describing how we build a model, that it goes all the way back here. Because it adds problems that are not the problems that are most interesting, changing to that variable. Okay, So for starters, what this says is if a bridge was built back in 1900, the chance is close to 0. If it was built in 2000, 2010, it's close to like 80, 90%. This is somewhat accurate up here. We know it's inaccurate down here. We did see that it was more like 20% if it was built early in the century. And that's because it's not able to take on whatever shape it wants. It can only take on a sigmoidal shape. I'm going to change this to use a cubic spline. Cubic spline is a way to allow a linear model to handle somewhat nonlinear relationships. So comes from the spline package, the NS. This makes it a particular case of what they call a generalized additive model. If you'd like to learn about generalized additive models, I really recommend this new course, Nonlinear Modeling in R with GAMS, by the brilliant instructor Noam Ross. And then we'll introduce this in some great detail. So I think this is a data camp course I definitely recommend. I'm going to just use, what I'm saying is I'm going to allow this not to be sigmoidal. I'm going to allow there to be a little more complications. I'm going to give it, in fact, 2 degrees of freedom to fit a model. So notice what happened. The shape that it fit, and I'm going to expand limits, add y equals 0. What it did is it allowed year built to affect the graph not just in one way, like, well, it's always going up. It really gave it 2 terms that it allowed it to use to fit it. And just from that, it was able to say, well, I think it's mostly flat for most of the 1900s, then it starts going up. The downside is that we added a term, we allowed for overfitting, but we have much more data than we have much more data than we have predictors, so I'm not even starting to worry about that. So with that, this is almost magic in terms of if I add add 2, now I have 3. Shape looks pretty similar. If I had 4, I don't know about you, but I kind of like this in terms of notice what's happening is that it says, oh, it's flat, and then it goes up. Okay. That's I think pretty interesting. And check this out. Now that I've added this term, I can actually say I want to add an extra term to the model. The extra term I'd like to add is responsibility, which I believe is currently just these ones and other. Yes. Is my NA gonna screw it up? Nah, my NA is fine. Don't worry about that. I've got to fix that in a second. What I did is say I allow responsibility to affect it linearly alongside the year that it was built. Now that I've added that, I can augment in my data and actually say, oh, I want a separate line for each responsibility. I'm exploring the effect that adding that term has to my predictions. What I learn is that, here it is, City Municipal Highway Agency and State Toll Authority look almost identical in my predictions. But I would predict that in a particular, just based on these couple of variables, but in a particular year, I think the County Highway Agency would tend to be more likely. I'm going to quickly make sure that we know this is predicted probability a bridge is rated good. And with that, say scale y continuous labels equals percent format. So I fit in a model and using, here I'm using augment. I forget the name of this type of graph, actually. I think it has a somewhat important name, but it's a graph of where the y-axis is our predictions. We get to explore our model based on, not on its coefficients, which are actually quite hard to interpret, especially once we have splines. In fact, I'm actually going to show what a summary of model look like. That's terrible. Look at this. We have an intercept. minus 2.8. What does that mean? Well, I could tell you it means that if something was built in the year 0, it was probably not going to be rated good. That's not a useful term, okay? We have 4 terms that represent, these are the 4 spline components of year built. No one can interpret this. It doesn't mean anything. Each of these numbers don't mean anything as a matrix. They mean something as a prediction. These do mean something. They mean that the county highway agency is probably the most likely to be good and other the least likely, but still nothing, it's still not nearly as easy to interpret as seeing these predictions. So that's the next step that we of what I learned. Now notice these are all the same shape. That's because I didn't allow the terms of responsibility and year to interact with each other. I didn't say, well, what year you are, whose responsibility it is and what year you are, the relationship over time might be different. I can add a term to this. I'm going to add a term of county. Remember, these were the 3 things. We also looked at average, we did also look at average traffic. I'm not going to look at that right now, but I'm going to add a term for county. And when I do, I need to change this graph as well. I need to say facet wrap by county, because I can't have something we predict on that I don't graph on. So this is a way of summarizing my model. My model combines time, responsibility, and county, and turns those into a prediction of how likely it is to be rated good just based on those factors. Okay. So what this basically would then show is that it suggests that Carroll County is probably the highest quality overall, especially ones from the county highway agency. But again, these aren't interacting. These aren't, and we actually notice there are no observations in Carroll County that were built by the City Municipal Highway Agency. This makes sense to me. All city municipal highway agencies are in Baltimore City, or at least maybe a few, it looks like, in Baltimore County. That's where these red lines are. So that's some things that we learned from this data. Okay. From this way of showing the plot. All right. So that was some things I looked at. An alternative way I could have graphed this would have been a coefficient plot. So in that case, we were still controlling for over time. So I'm going to show one last plot. I'm going to say controlled for the change in time for the overall trend in change over time, which again, it wouldn't be good if there were different changes over time within each county or within each city. But we could say controlled for the overall rate of trend and change over time. What's the let me see, just check. Yeah. What's the effect of being in a particular county or responsibility? What I would say then is take a look at our model. A lot of coefficients there. I'm going to tidy them, put them into Broom, and I'm going to look only at responsibility and county. Intercept is about the year 0, doesn't really mean anything. These are very hard to interpret, but I'm going to use the filter step. So now that it's in Broom, we've tidied this into a data frame. String detect, term, responsibility, or county. Okay? And now I'm going to graph them. I'm going to say term, estimate. I'm actually going to flip those and throw them in a geom point. And I'm going to do one last thing where I take the term and I reorder the term by the estimate. So I get a nicely... Oops. Here it is. What I'm showing is what do we think the influence is of it's ruled by the county highway agency while controlling for, again, the change over time? It looks like that's a positive influence in terms of whether it's rated good. What do I mean by positive? I mean estimate greater than 0. I'm going to quickly throw in a geom v line, color is red, line type is dashed, at x-intercept 0. I'm going to do one other thing, which is really quite neat, which is I'm going to add confidence intervals. Conf int is true. Is that right? That should add 2 columns, conf low and conf high, to each of these estimates. And now I can add geom error bar h, x min equals conf low, x max equals conf high. So this is called a coefficient plot. Excuse me. Yeah. That puts this in a lot more context. Okay. All right, really, really good to know. All right, this is showing the estimates of each of these terms. Now, how do I interpret an estimate? That it takes a lot of practice. It's about a term called log odds. This is about how much does it change the odds that you are rated as good. It's designed that way. It's designed that way because you can't just say, oh, it becomes 10% more likely, because then you could go right over 100% or right under 0. But odds work in this pattern. But again, that takes a lot more interpretation and some practice, and certainly some discussion. So we just know that positive means more likely, negative means less likely. What's important, now that I'm taking a look at the confidence intervals, is that here I was saying there are trends, even on my last graph, where I looked at their responsibility over time, the predictions, I was making the mistake of saying, oh, notice this curve lies above this curve. Yes, but the change was not significant according to the logistic regression. That was a big no-no of me to start looking at the predictions without actually looking at the p-values of the confidence intervals. So hopefully all the statisticians watching this were yelling at me. Oops. But let's take a look at these confidence intervals. If they overlap 0, that means that generally means the p-value is greater than 0.05. These are 95% confidence intervals. That's what Broom is calculating for them. And there are 2 terms, Carroll County and County Highway Agency, that in this regression don't quite overlap 0. Having said that, we are testing 1, 2, 3, 4, 5, 6, 7, 8, 9 different hypotheses here. So we can't necessarily say even that these 2 being significant are meaningful. That might just be getting down to data dredging, where we're testing we have a lot of factors here. So I would actually say from this conclusion that we haven't found evidence of a trend of an effect of geography or ownership on bridge condition once we control for time. Okay, so that was some addition of inference. And particularly, we were dealing with inference with the most complicated thing we did today was adding that spline, where we said allow it to take on shapes that are not necessarily that are not linear. As we can see, if I just make the simple version of this one more time. Oops. I should probably call this the simple model, where we only have year built. Yeah, allowing this trend where it's not quite a linear trend. Okay, that was one thing I introduced today, and the general idea of using this type of graph to understand what your model is predicting, as well as that's a conclusion from Broom's augment, as well as using Broom's tidy to create a coefficient graph, and in this case learn there isn't a big difference across responsibilities or counties. All right, that concludes this week, where we took a look at Maryland bridges. We took a look at we saw that it has an effect of change over time. We tried looking at combinations of time and responsibility, as well as time and county. We made a couple of maps. We saw the general shape of Maryland. I would say if I'd had more time and a little more experience, I probably would have made an interactive map. This is definitely or made a map that included the actual geography of the Baltimore area on it, as opposed to just the outline of the state of Maryland. Those are things that can be done with a GG map package, which I didn't use today. And we did some fitting of linear model and some tidying using the augment and tidy functions. Okay. I hope you had fun. I certainly did, and I'll see you next week.